Dear students, welcome back to a new mathematics session. In today's session, we shall discuss problems from exercise 7.11 from the chapter Integrals. We will solve these problems by using properties of definite integrals. Let's move on to the topic. Before starting the session, let's recall the properties of definite integrals. The first property is integral a to b f of x dx is equal to integral a to b f of t dt. Here the variable of the function is not a matter if the limits are same. Means the upper limit and lower limits are same. Here integral a to b f of x dx is equal to integral a to b f of t dt. When you check here, the lower limit is a and the upper limit is b. Here also the same thing, the lower limit is a and the upper limit is b. In the first case, LHS part the function in terms of x, and the second on the right hand side the function is in terms of t. So this is the first property, integral a to b f of x dx is equal to integral b to a f of t dt. The second property is integral a to b f of x dx is equal to minus of integral b to a f of x dx. Here what we have done is just we have interchanged the limits. First of all, in the LHS part it is a to b, and in the RHS part it is b to a, provided there is a minus sign. So the second property is integral a to b f of x dx is equal to minus of integral b to a f of x dx. Here there is a particular case also. Here integral a to a f of x dx is equal to 0, means the upper limit and the lower limits are same, means the integration of that particular function value is 0. Then the third property is integral a to b f of x dx is equal to, we can split the limits, integral a to c f of x dx plus integral c to b f of x dx. Here a to b we are splitting as a to c and c to b. This is the third property. And the fourth one is integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. What we have to do is the upper limit and lower limit we have to add, and we have to subtract the variable. So a plus b minus x, integral a to b f of a plus b minus x dx. And the next property is integral 0 to a f of x dx is equal to, here the lower limit is 0 and the upper limit is a. So integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx, means upper limit you have to take and minus it with the variable. So f of a minus x dx. The next property is integral 0 to 2a. The previous property was integral 0 to a, and here the limit is 0 to 2a f of x dx is equal to integral 0 to a f of x dx plus integral 0 to a f of 2a minus x dx. So this is the way we have to split the integrals, means integral 0 to 2a f of x dx is equal to integral 0 to a f of x dx plus integral 0 to a f of 2a minus x dx. This type of properties, when we apply it in the problems, it will be more clear for you. Then the next property is integral 0 to 2a f of x dx is equal to 2 into integral 0 to a f of x dx if f of 2a minus x is equal to f of x, and integral 0 to a f of x dx will be equal to 0 if f of 2a minus x is equal to minus of f of x. So first of all you have to find out f of 2a minus x, means this upper limit you have to take f of 2a minus x. If you get as f of x, then the integration can be done by using 2 into integral 0 to f of x dx. Then if you find out f of 2a minus x, and if you get as minus of f of x, then we can write the integral value as 0. Then the last property, that is integral minus a to a. So this is the first property by using negative and positive upper and lower limits. Integral minus a to a f of x dx is equal to 2 into integral 0 to a f of x dx if f is an even function. How do we check the function is even or not? This is the way. If f of minus x is equal to f of x we get, then we can say that it is an even function. Once it is an even function, we can write as 2 into integral 0 to a f of x dx. And if it is an odd function means if you find f of minus x, you should get minus f of x. We have discussed some example in the previous class. So This will be useful to solve such type of questions. The second property is minus a to a f of x dx will be equal to 0 if f of x is an odd function. So before proceeding to the next session or the next problems, we have to make sure that you are very familiar with these properties. Altogether 8 properties are there, starting from 0 to 7. Next we shall discuss the exercise problems. First question from exercise 7.11. By using the properties of definite integrals, evaluate the integrals in exercises 1 to 19. The first question is integral 0 to pi by 2 cos square x dx. So here when we check the limits, the lower limit is 0 and the upper limit is pi by 2. So let's take this one as I is equal to integral 0 to pi by 2 cos square x dx. Let it be equation number 1. So the given function as it is we have taken and we have marked it as equation number 1. Now integral 0 to pi by 2, that is the limit. So we have learned a property from 0 to a, integral 0 to a f of x dx is equal to f integral 0 to a f of a minus x dx, means upper limit you have to take and subtract with the variable here. So integral 0 to a f of a minus x dx. Now instead of a, here pi by 2 is there, our variable is x. So this can be written as I is equal to, the limit is same, integral 0 to pi by 2 cos square. This variable we will change as f of a minus x. What is a? Here a is pi by 2. So pi by 2 minus x. This x will be changing as pi by 2 minus x dx. As we know that cos pi by 2 minus x, cos pi by 2 minus x is sine x. So here cos square pi by 2 minus x, that means sine square x. Once again, cos pi by 2 minus x is sine x. Because of that, cos square pi by 2 minus x is sine square pi by 2. So I is equal to integral 0 to pi by 2 sine square x dx. So label it as equation number 2. Now the next procedure is we have to add equation number 1 and 2. But how we have got equation number 1? The function as it is we have to take as I is equal to integral 0 to pi by 2 cos square x dx. Since the limit is from 0 to pi by 2, we have to use 0 to a f of x dx property, that is f of a minus x dx. So when we put a minus x, means here pi by 2 minus x. So cos pi by 2 minus x is sin x, cos square pi by 2 minus x is sin square x. That we have to label it as equation number 2. Then the procedure is 1 and 2 we have to add. So here left hand side I is there, here also I is there. So I plus I is 2i. Then here 0 to pi by 2 limit, here also 0 to pi by 2 limit. So when we take common, the first part there is cos square x, and in the second part there is sin square x. So cos square x plus sin square x. We know that cos square x plus sin square x is 1. So 0 to pi by 2 1 dx. Then we know we are just familiar with this integral of 1 dx, that is integral of 1 dx is x. Then the limit we have to apply 0 to pi by 2. So upper limit minus the lower limit, that means x replaced with the pi by 2, then minus x replaced with the 0. So pi by 2 minus 0, that is pi by 2 will be coming on the right hand side. Left hand side as it is 2i is equal to pi by 2. Then we need I value, this one is I. So I we can take, bring this 2 to the denominator, that is I is equal to pi by 4. So this is the answer. Next we shall discuss the second question, 0 to pi by integral 0 to pi by 2 root sin x by root sin x plus root cos x dx. Here also the same, just like the previous one only, integral 0 to pi by 2 means integral 0 to a property we have to use. Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. So that is the formula. So each and every time when you write the when you go through the question, you just recall the property, if possible all the properties, and write the concerned property here which we are going to apply. Okay, that is, let's take this one as I, the same procedure as before. I is equal to the given function we have taken, label it as equation number 1. Then we have to write the property, that is integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Then apply the property here, that is I is equal to integral 0 to pi by 2 root sin x is replaced with pi by 2 minus x, a minus x, upper limit minus the variable, okay, a minus x. So sine of, here upper limit is pi by 2 minus x divided by root of sine pi by 2 minus x plus root of cos x will be coming as cos pi by 2 minus x. We know that sine pi by 2 minus x is cos x and cos pi by 2 minus x is sin x. Apply it. I is equal to integral 0 to pi by 2 root of sine pi by 2 minus x, that is root cos x, root of sine pi by 2 minus x, again root cos x, plus cos pi by 2 minus x is sin x. All these trigonometric formulas we have learned in class 10 and 11. So if you don't know, if you are unable to recall it, write it on the right hand side. Right side of each and every step, the formulas you have to write if you don't know. Then label it as equation number 2. Then as per the algorithm, the next step is adding these two equations, equation number 1 and 2. Then I plus I, that is 2i, equal to 0 to pi by 2 is common in both equations. Write it outside. Then first equation is concerned, root sin x by root sin x plus cos x, it is written, plus 0 to pi by 2 is outside, root cos x plus sin x. Then this right hand side denominator, if you check, in both the terms it is a root sin x plus cos x is common, so let it be common LCM. Then here root sin x plus root cos x, since the denominators are same, you just add the numerators, that is a property. Then root sin x plus cos x by root sin x plus cos x, numerator and denominator is same, we can cancel and write it as 1, 0 to pi by 2, 1 dx. And we know that integral of 1 is x, so apply the limit 0 to pi by 2. When you apply the limit, upper limit minus lower limit, that means pi by 2 minus 0, that will be pi by 2. So 2i is equal to pi by 2. Then I will be equal to this 2 we can bring to the right hand side, which will come to the denominator. Denominator already there is a 2. So pi by 2 into 2, that is I is equal to pi by 4. So this is the answer for the second question. Move on to the third question. Third question also same like the previous two questions. The same property is applying here. 0 to pi by 2, something is given, that is in the form 0 to a, integral 0 to a f of x dx is integral 0 to a f of a minus x dx. That is a property we are going to use. As before, label it as write it as equation number, write it as I and label it as equation number 1. Then apply the property integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Means pi by 2 minus x. This x should be replaced and write it as a minus x. Here a is pi by 2. Pi by 2 minus x. So I is equal to integral 0 to pi by 2 sine power 3 by 2 into this x is replaced as pi by 2 minus x. Then denominator also same thing, sine power 3 by 2 of pi by 2 minus x plus cos power 3 by 2 of pi by 2 minus x. As we know that sine pi by 2 minus x, that is cos x. Here sine power 3 by 2 of pi by 2 minus x, that means cos power 3 by 2x. Here also same thing, cos will be changing as sine. So integral 0 to pi by 2, this will be changing as cos. So cos power 3 by 2x divided by this changing as cos, that is cos power 3 by 2x. This will change as sine. So sine power 3 by 2 into x. Label it as equation number 2. Procedure we know, we have to add first and second equations for the next step. Then I plus I will be coming as 2i, 0 to pi by 2 is common. Then it is quite familiar here. See, sine power 3 by 2x plus cos power 3 by 2x. The denominator is same for both the equations. So just consider as a common denominator or common LCM. Since the denominators are same, what we can do? Numerators simply we can add. So sine power 3 by 2x plus cos power 3 by 2. Cos power 3 by 2x. Both numerator and denominator is same, we can cancel and we will get as 1. So integral 0 to pi by 2, 1 dx. So integral 1 dx, we know that it is x. Apply the limit 0 to pi by 2, upper limit minus lower limit, pi by 2 minus 0, that will be coming as pi by 2. So 2i is equal to pi by 2 will be coming, so I will be equal to pi by 4. Some step I have avoided here because we have done it in the previous calculations. So directly we can write, it's not an issue. So I is equal to pi by 4. Move on to the fourth question. Fourth question also similar to the first three questions. The limit and the property we are going to apply, both are same. So 0 to pi by 2 cos power 5x divided by sine power 5x plus cos power 5x dx. So as before, we can take this one as I, then apply the property integral 0 to f of x dx is equal to f of a minus x dx. So here instead of x we will be substituting as pi by 2 minus x, and mark it as equation number 1 and 2, then add equation 1 and 2, then cancel the common terms and apply the integration formulas. So this question you will try it as homework. Next we shall discuss the fifth question, that is integral minus 5 to 5 mod x plus 2 dx. And while discussing properties of definite integrals, we have learned a special property, that is splitting the limits for solving these type of modulus functions. So that is what we are going to do here. So first of all, take this one as I and take this x plus 2 and equate with 0. X plus 2 equal to 0 means we'll be getting x is equal to minus 2. And clearly minus 2 is between minus 5 and 5. So minus 2 is between minus 5 and 5 means we can write this like this. This is minus 2 is lying between minus 5 and plus 5. Minus 5 and plus 5. So now we can split the limit as minus 5 to minus 2 one group and minus 2 to 5 another group. And when we take minus 5 to minus 2, the function will take its negative form, that is minus of x plus 2. And from minus 2 to 5, it will take the positive form, that is x plus 2. So the property we are going to use is integral a to b f of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx. Actually minus 5 to 5 is given to us, so we are taking another one point which is in between minus 5 and 5, that is minus 2. So c will be minus 2 here. So integral minus 5 to minus 2, first part minus 5 to minus 2. When we take this minus 5 to minus 2, the function will take its negative form, that is minus of x plus 2 dx, plus the next is minus 2 to 5 integral x plus 2 dx. So this is as per the, we are splitting as per the definition of modulus functions. Okay, the first part will go for the negative form and the second part will be going for the positive form. Then next is in this minus of x plus 2, minus we can keep outside, and when we take the integration, x integral is x square by 2. Integral of x is x square by 2 plus 2 into integral of 1, that is x, so 2x. Then apply the limit, upper limit and lower limit, plus here also the same thing, integral of x is x square by 2 plus 2 into integral of 1, that is integral of 1 is x, so 2 into x is 2x. Then apply the limits, that is minus of, when we apply 2 here upper limit, that means minus 2 square, minus 2 square is 4, so 4 by 2 minus, here plus and there is a minus sign here, plus into minus, minus 2 into 2, 2 into 2 is 4, minus, then upper limit minus lower limit. Now we are going to apply this one, minus lower limit means minus 5 is the lower limit, so x square, that is minus 5 the whole square, that is 25 by 2. Then again there is a minus sign, so minus 5 into 2, that is minus 10 will be coming, so that is minus 10. So this is upper limit minus the lower limit, and here this minus sign is coming. When we apply the limit, here you can see x square, that is minus 2 square is 4, 4 by 2. Then here plus is there, but here there is a minus sign, so 2 into minus 2 is minus 4, that's why this minus 4 came. Same way this minus 10 also came here, plus here upper limit when we apply 5 square is 25 by 2, then plus 2 into 5, 2 into 5 is 10 minus the lower limit, that means here minus 2 is the lower limit, minus 2 square, that is 4 by 2, then plus 2 into minus 2, 2 into minus 2 is minus 4, so that is minus 4 here. Then here 2 minus 4, 2 minus 4 is minus 2, and here 25 by 2 minus 10. So when you take LCM here, 2 into 10, 2 into 10 is 20, so 25 minus 20, 25 minus 20 is 5, 5 by 2. So this bracket we have done the calculation and written here, 2 minus 4 is minus 2, and here LCM we have taken 2 into 10, 20, 25 minus 20 is 5 by 2, plus this plus. Then here 2 LCM, if you take 2 into 10, 20, 20 plus 25 is 45, 45 by 2 is written here. Then 4 and 2 cancelling, 2 will be coming, 2 minus 4, that is minus 2, minus into minus plus 2 is here. Okay, so some steps we have avoided, some mental calculation we have done. Then here when we check, remove the bracket, minus into minus plus 2, minus into minus plus 5 by 2, plus 45 by 2, then plus 2 is written. Then here 2 plus 2 is 4. Now you can see there is common denominator 2. So if common denominator comes means we can just add the numerators. 5 plus 45, 5 plus 45 is 50, 50 by 2. That is 50 by 2 is 25. So 4 plus 25, that is equal to 29. So this is the answer. Next we shall discuss the sixth question, integral 2 to 8 mod x minus 5 dx. This is also a modulus function, so we are going to use splitting the limits, okay, property. So now when we take x minus 5 and equate with 0, so when we take x minus 5, when we equate with 0, x minus 5 is equal to 0, we will be getting the value of x as 5, x is equal to 5. Now it is quite clear that 5 is in between 2 and 8, so 2 less than 5 less than 8. Okay, now we have splitted the limit, 2 to 5 one limit and 5 to 8 another limit. Okay, so now we are just writing by using the definition of modulus function, mod x minus 5 is equal to, it will take the positive value when x is greater than or equal to 5. When x is greater than or equal to 5 means this portion 5 to 8. Okay, so x minus 5 positive value, then it will take its negative value minus of x minus 5 when x is less than 5. When x is greater than or equal to this value, it will take the positive form, and when x is less than this value, it will take the negative form. So minus of x minus 5, we can write it as, when we take this minus inside, 5 minus x will be coming if x less than 5. So we will calculate the integral, that is integral 2 to 8 mod x minus 5 dx is equal to integral 2 to 5. 2 to 8 is the integral, so we are splitting as 2 to 5. Okay, 2 to 5 means it is less than 5. 2 to 5 means it is less than 5, that means negative form. Negative form means this one, 5 minus x. So 5 minus x dx plus the next portion is integral 5 to 8. 5 to 8 means when x is greater than or equal to 5. When x is greater than or equal to 5 means x minus 5 form. So integral 5 to 8 x minus 5 dx. Then directly apply the integration, that is here 5 integral of 5 or 5 into integral 1 dx. Integral 1 dx is x, so 5 into x is 5x minus integral of x is x square by 2. Apply the limits, plus here x integration is x square by 2 minus 5 into integral 1 dx is x. 5 into x is 5x. So apply the limits. Now we will apply 5 into upper limit, that means 5 into 5 25 minus 5 square. 5 square is 25 by 2 minus the lower limit, that means 5 into 2, that is 10 minus 2 square. 2 square is 4, 4 by 2 is 2, then plus, this plus is there, then 8 square. 8 square is 64, 64 by 2 is 32 minus here this minus. Okay, here that minus is there, then 8 into 5, 8 into 5 is 40 minus the lower limit. Lower limit is 5, here just substitute 5 into 5, that is 25 by 2 minus 5 into 5, that is 25. So here once again lower limit, when we apply 5 into 5 25 by 2 minus 5 into x is there, x replace and put with 5, 5 into 5 is 25, that is equal to here 25 minus 25 by 2, then minus 10 minus 2, 10 minus 2 is 8, then plus 32 minus 40, 32 minus 40 is minus 8, that is written here, then remove this bracket, minus 25 by 2, then minus into minus plus 25, then that is equal to here 25 plus 25 50 minus 8 minus 8, that is 16 minus 16, so 50 minus 16, 50 minus 16 is 34, then here 25 by 2 and here 25 by 2, common denominator is there 2, that means you can just add the numerators, 25 minus 25 minus 25, that is minus 50 by 2, minus 50 by 2 is minus 25, so 34 minus 25, the answer we are getting is 9. Next we shall discuss the seventh question, integral 0 to 1 x into 1 minus x the whole power n dx. So here also when we observe the limit, it is 0 to 1, means 0 to a property we can use. Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. That is what we are going to apply. So let's take this one as I, and integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. By using that property, instead of here x, it should be replaced and put the upper limit minus the variable. So here the upper limit is 1 and the variable is x. So x should be replaced as integral 0 to 1. X should be replaced as upper limit minus the variable, that means 1 minus x. So this x is replaced as 1 minus x into this 1 is same, and this x is replaced as minus of 1 minus x. Once again, by using this property, f of x is replaced as f of a minus x. So here a is 1, x is x itself, so 1 minus x will be coming. instead of x. So x replace and put 1 minus x. Here also x replace and put 1 minus x. The rest of the things are same. That is integral 0 to 1. 1 minus x remains the same. Here remove the bracket. 1. Then when we remove this bracket, minus into 1 is minus 1. Minus into minus plus. Then x is there inside, the whole power n dx. Then integral 0 to 1. 1 minus x into, here 1 minus 1 is 0. Only x is there. X power n dx will be coming. Then again here remove the bracket, that is integral 0 to 1. 1 into x power n, that is x power n, minus x into x power n. So here power of x is 1. And when we multiply the bases, we will add the exponents. So here 1 is there, here n is there. So 1 plus n will be coming, x power 1 plus n, that will be n plus 1 dx. Then now it is non-format for us, so just we can integrate. That is integration of x power n, we know, that is x power n plus 1 by n plus 1, minus integration of x power n, we know, x power n plus 1 by n plus 1. So here already n plus 1 is there. So what we'll be doing is n plus 1 is there. Integration during time, one more 1 will be added, n plus 1 divided by the same thing only here, n plus 1 plus 1, n plus 1 plus 1. So what will be coming as a result? That will be n plus 1 is 2. So x power n plus 2 by n plus 2. That is what this one came. Then apply the limit integral 0 to 1. 1 power n plus 1. 1 power n plus 1 is 1 divided by n plus 1 minus, this minus is there. Then 1 power n plus 2. 1 power n plus 2 is same. 1 power any quantity is 1 itself. So 1 divided by n plus 2 minus the lower limit. Lower limit is 0. So when we apply 0 here, it will, both terms will be 0. So 0 minus 0. So this is the upper limit and this is the lower limit. Then here n plus 1 into n plus 2 we can take as common LCM. Then multiply this n plus 2 with 1. So 1 into n plus 2 is n plus 2. Then this n plus 1 with 1. There is a minus sign. So when we remove the bracket, minus n minus 1. Okay, this way multiplication, 1 into n plus 2 is n plus 2, minus 1 into n plus 1 is minus n minus 1. Then here plus n and minus n we can cancel. So just we will show it, that is plus 1 and minus 1 we can cancel. Then finally we will be getting as 2 minus 1. 2 minus 1 is 1 divided by n plus 1 into n plus 2. So this question is just not like the common algorithm we are using. Previously while applying 0 to a f of x dx format, what we have done is equation number 1 and equation number 2 we have taken, then we have added. But here we, while applying this property itself, we are getting a non-format. So that's why just a difference is there while comparing with question number 1, 2, 3 and all. Okay. Next we shall discuss the 8th question, integral 0 to 4 log 1 plus tan x dx. So here also the property, when we see the limit itself, the property should come to our mind. This is in the form 0 to a f of x dx. That means integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. So that is the property we are going to use. Just like the common algorithm we can use. Let it be I is equal to integral 0 to pi by 4 log 1 plus tan x dx. Label it as equation number 1. Then apply the property. Here x should be replaced with pi by 4 minus x. That means I is equal to integral 0 to pi by 4 log 1 plus tan. This x will be replaced as this format, a minus x. Here a is pi by 4. So pi by 4 minus x dx. Now when you see this portion, that is tan pi by 4 minus x, that is in the form tan of a minus b. We know that tan a tan b, tan a minus tan b divided by 1 plus tan a tan b. This is the expansion. So tan of pi by 4 minus x is tan a minus tan b. That means tan pi by 4 minus tan x divided by 1 plus tan a tan b. That means 1 plus tan pi by 4 into tan x. Tan pi by 4 we know the value, it is 1. So 1 minus tan x by 1 plus here also 1 tan x. 1 into tan x is tan x. So finally we are getting as 1 minus tan x by 1 plus tan x. That we can replace here. Integral 0 to pi by 4 log 1 plus, this portion will be coming as 1 minus tan x by 1 plus tan x dx. That is integral 0 to pi by 4 log, take this one as common LCM, 1 plus tan x. So this quantity will be multiplying here 1 into 1 plus tan x, that is 1 plus tan x, plus here there is 1 minus tan x as it is will be coming. Then here when we check the numerator, there is plus tan x and there is minus tan x, both can be cancelled. Then integral 0 to pi by 4 log, here 1 plus 1, that is 2 divided by 1 plus tan x dx. Label it as equation number 2. Still now it is not in the common format, known format. So what we can do? Normal procedure. Just we will add equation number 1 and 2. So here I plus I, this is also I. So I plus I is 2I is equal to 0 to pi by 4 is common. Just to take integral 0 to pi by 4. First term is log 1 plus tan x, that is there, plus second term is log 2 by 1 plus tan x dx. Then integral 0 to pi by 4 log, this is in the form log a plus log b. So log a plus log b is log a into b. So here logarithm is outside, a into b. So this is a and this is b. So log a into b means log 1 plus tan x into 2 by 1 plus tan x. Now when we check, it is coming as 0 to pi by 4. Here this numerator and denominator, there is 1 plus tan x and 1 plus tan x can be cancelled. And inside the bracket it will be having only 2. So 0 to pi by 4 log 2 dx. Log 2 is a constant. So 2I is equal to log 2 into integral of integral of 1 dx. Because log 2 we can keep it outside. Only one balance. Integral of 1 dx is x. So x 0 to pi by 4. We are going to apply the limits. That is equal to, here pi by 4 minus 0. Pi by 4 minus 0 is pi by 4. So pi by 4 into log 2. That is what the calculation. Then 2I is equal to pi by 4 into log 2. I is equal to this 2 we can bring to the right hand side, come to the denominator, 2 into 4, that is 8. So pi by 8 into log 2. So this is the answer. Next we shall discuss the 9th question, integral 0 to 2 x into root of 2 minus x dx. So here when you check the limit, it is 0 to a form. So integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. So this is what we are going to use, that property. So let it be I is equal to integral 0 to 2 x into root of 2 minus x dx. Then by using this property, x should be replaced as 2 minus x, a minus x. Here a is 2. So it will be coming as integral 0 to 2 x is replaced as 2 minus x. So 2 minus x into root of 2 minus of 2 minus x. This x is replaced as 2 minus x dx. When we remove the bracket, these 2 and these 2 will be cancelled. The balance will be coming as 0 to 2, 2 minus x into root x dx. So this one, when we remove the bracket, the integration is quite easy here. So the rest of the portions you will be trying as homework. Move on to the 10th question, integral 0 to pi by 2, 2 log sine x minus log sine 2x dx. So let it be I, integral 0 to pi by 2, 2 log sine x minus log sine 2x dx. The property is identified here, it is 0 to a, integral 0 to a f of x dx is equal to f of 0 to a f of a minus x dx. That is the format we are going to use. Now we will not be writing those properties and all, we will do the mental calculations. Now a little bit of arrangement we have to do, that is 0 to pi by 2 log, this is m log n, that is equal to log n power m format. That means this 2 will be coming as a power of this one. So log sine square x. Okay, this is in the form m log n. So that is the answer will come as log n power m. So this 2 will be coming as a power of sine. So log sine square x minus here log sine 2x as it is will be coming into dx. 0 to pi by 2, this is log a minus log b, that is log a by b. So log sine square x by sine 2x. If you don't know the formulas, just write it. I am just explaining it. I am not showing here because these are all common formulas. If you don't know, just write and keep by just listening. Here log a minus log b, log a minus log b is log a by b, that is sine square x by sine 2x. Then 0 to pi by 2 log sine square x divided by sine 2x formula we know, that is 2 sine x cos x. From here 1 sine x will be cancelled. Numerator there are 2 sines are there, so this is 1 will be gone, here also 1 will be gone. That is I is equal to integral 0 to pi by 2 log, there is 2 is in denominator, 1 by 2 sine by cos is tan x dx. Now this is simplified form, let it be equation number 1. Now we will apply the property 0 to a f of x dx is equal to 0 to a f of a minus x dx. Means x is replaced and substitute as pi by 2 minus x. That is integral 0 to pi by 2 log 1 by 2 into tan. Here only x is there. So x is replaced as pi by 2 minus x. So tan pi by 2 minus x dx. We know tan pi by 2 minus x, that is cot x. So 0 to pi by 2 log 1 by 2 tan pi by 2 minus x will be coming as cot x. Label it as equation number 2. Now as before, adding equation number 1 and 2. I plus I, that is equal to 2i. 0 to pi by 2 is common. Then here log 1 by 2 tan x plus log 1 by 2 cot x. That is what it is written. That is 2i is equal to 0 to pi by 2 log 1 by 2. This is a plus log a plus log b. That is log a into b. This is a and this is b. So log 1 by 2 tan x into 1 by 2 cot x. Now 0 to pi by 2 log tan x into cot x. We know both are reciprocal ratios. Tan x into cot x, when we multiply, we will get as 1. So 1 into 1 by 2 into 1 by 2, that is 1 by 4. So log 1 by 4 dx. That is log 1 by 4. This is a constant. Keep it outside. Integration of 1 dx. Only 1 is there because this is constant. Okay. Integration of 1 dx. That is x. Apply the limit to 0 to pi by 2. So log here, when we apply this one quotient rule, log a by b, that is log a minus log b. That is what it is written. Log 1 by 4 we can write it as log 1 minus log 4. Then here when we apply the limit, upper limit minus lower limit. Upper limit is pi by 2 minus 0. Pi by 2 minus 0 is pi by 2. So log 1 minus log 4 into pi by 2. Now log 1 we know it is 0. So 0 minus log pi by 4 is minus log pi by 4. Sorry. 0 minus log 4 is minus log 4. So minus log 4 into pi by 2. That is pi by 2 log 4. There is a minus sign. Minus pi by 2 log 4. Because log 1 is 0. Equal to minus pi by 2 log 4. Here 2i is equal to minus pi by 2 log 4 will be coming. Then 2i means we want only I. So I is equal to that 2 will be bringing to the right hand side. It will come to the denominator. That means minus pi by 4 will be coming. This 2 will change to 4. Minus pi by 4 log 4. Then this is minus pi by 4 log 4. We can write it as 2 square. So minus pi by 4 log 2 square. That is equal to minus. Here this is, you can see, log m power n. That means n log m will be coming. That means 2 will be coming here. Then along with the pi 2 will be coming. So 2 pi log 2 by 4. That is what the answer. 2 pi divided by 4 into log 2. That is equal to 2 and 4 we can cancel. Then will be coming as pi by 2 minus pi by 2 log 2. So this is the final answer. Next we shall discuss the 11th question. Integral minus pi by 2 to pi by 2 sine square x dx. So here when we check the limits, by checking the limit only we need to identify which property we are going to apply here. See, this is in the form minus a to a f of x dx. So there is a property we have learned, that is the last property, integral minus a to a f of x dx is equal to, it takes two values based on the function f of x. So if f of x is an even function, it will come as 2 into integral 0 to a f of x dx, or if it is an odd function, it will take the value 0. So to identify whether it is an even function or odd function, first of all we have to find out f of minus x. F of minus x is equal to f of x, then it is an even function. If f of minus x is equal to minus f of x, then it is an odd function. Somewhat different way we are going to do this question. There are some verifications and all there, like even or odd and all. So we must note these things. So first of all, let's take it as I and take the function f of x is equal to sine square x. Here sine square x is actually, we can write it as just you know that it is sine square x, we can write it as sine x the whole square. Okay, sine x the whole square. By keeping this one in mind only we are doing the rest of the calculation. Then f of minus x we have to calculate. F of minus x, when we put, that is sine square of minus x. Sine square of minus x means actually it is in the form, just I will show you. Here we will substitute, that will be little clarity will be there. That is sine of minus x. Okay, sine of minus x the whole square will be coming. Sine of minus x the whole square. Actually sine of minus x, when we check, it is we know that it is minus sine x. So minus sine x the whole square, minus sine x the whole square. Minus square is there, minus square is plus, so it will be coming as sine square x. So that is the way we have got these steps. Okay, sine square x, that sine square x is what? It is f of x. So f of minus x we will calculate, and then we have got f of x. So these two way we have done. Which one is easy for you to understand, that you can choose. Sine square x I have taken as sine x the whole square. Then when we substitute f of minus x, sine of minus x will be coming. Sine of minus x is minus sine x. When we take square, it will be sine square x. Minus will be plus. Sine square x is our f of x. So f of minus x is equal to f of x. That means it is an even function. F of x is an even function. Even function means this is the way we have to write. That is integral minus a to a f of x dx is equal to 2 into integral 0 to a f of x dx. So 2 into integral 0 to a. This minus a is gone. So 0 to a f of x dx. That means I is equal to 2 into, that is 2 into 0 to a is pi by 2. So 0 to pi by 2 sine square x dx. Label it as equation number 1. Now again another property we are going to apply. You see here now it is in the form 0 to a, integral 0 to a f of x dx. 0 to a coming means we will be writing as f of a minus x dx. That is I is equal to 2 into integral 0 to pi by 2 sine square x is replaced as a minus x. That means pi by 2 minus x dx. So that property I am not writing because it is quite familiar for us now. Then I is equal to 2 into integral 0 to pi by 2 sine pi by 2 minus x is cos x. So sine pi by 2 minus x will be writing as cos x. So sine square pi by 2 minus x is cos square x dx. Label it as equation number 2. Now what we can do, add equation number 1 and 2. I plus I will be getting as 2i. Here there is 2 is common, take it out. 0 to pi by 2. Here sine square x, that is written, plus cos square x dx. Sine square x plus cos square x, we know that is 2i is equal to 2 into integral 0 to pi by 2. Sine square x plus cos square x is 1 dx. That is integration while doing 2 into x will become integration of 1 dx is x. Apply the limit 0 to pi by 2. Upper limit minus lower limit, that is 2 into pi by 2 minus 0. Pi by 2 minus 0 is pi by 2. 2 cancel, and finally we are getting the answer as pi. Dear students, today we have solved question number 1 to 11 from exercise 7.11 by using the properties of definite integrals. After solving these questions, please make sure that you are able to solve these questions independently and try it in a separate sheet of paper. While solving, if you have any doubt, please mark it and keep. We will discuss it during the discussion session. Thank you for watching.